Have you ever seen those incredible photos or videos of the ocean just glowing at night? You know, where the waves crash and erupt in these brilliant flashes of blue and green light. It looks absolutely magical, right? But what if I told you that stunning beauty is actually a disguise? That what we're seeing isn't a light show, it's a war. Let's dive in.
Yep, you heard that right. This isn't just some pretty, passive phenomenon. It is a high-stakes conflict, a desperate fight for life that's playing out in every single drop of that glowing water.
So the big question is, what is this war really all about? And who are the microscopic warriors that are lighting up the battlefield? Well, that's the mystery we are going to solve together today.
All right, so first things first in our investigation. We need to identify the culprits. Who or what is actually making all this light? These aren't some mythical sea creatures. They are very real and they are fascinating.
Okay, so meet our culprits. They're called Dinoflagellates. And their name is actually a perfect description. It comes from the Greek for whirling and the Latin for whip. And that's exactly what they do. They use these two tiny whip-like tails to spin and whirl their way through the water. These little guys are the architects of the ocean's glow.
Now think of this as our rogues gallery of the main suspects. You've got the famous sea sparkle or Noctilucus scintillans, which is known for its super brilliant flashes. Then there's Lingolodendinium polyedrum. That's the one responsible for those incredible glowing red tides you see off the coast of California. And some, like Goniolax here, have a bit of a dark side. They also produce some pretty potent toxins.
So we know who is making the light, but how? How does a tiny, single-celled organism create its own light? Well, let's break down the anatomy of their secret weapon, that incredible bioluminescent flash.
So inside each and every one of these tiny cells is a super sophisticated chemical toolkit. It has three main parts. First, you've got luciferin. Think of that as the fuel for the light. Then there's luciferase. That's the enzyme that acts like the spark plug or the ignition switch. And it all happens inside these things called scintillans. They're basically tiny pouches where the whole light-making reaction takes place. And this is how it all goes down. It's basically a pH-powered light switch, and it happens incredibly fast. So, step one, something disturbs the cell. A wave, a fish, anything. That disturbance triggers a rush of protons into those little scintillon pouches. This instantly makes the inside of the pouch acidic. That acid bath activates the luciferase enzyme, which then ignites the luciferin, and bam! A flash of blue-green light is released. The whole thing happens in a fraction of a second. It's just amazing.
And get this, it's not even on all the time. They have a built-in clock. These dinoflagellates only arm their light weapons at night. During the day, they're busy doing other things, like photosynthesizing and basically recharging their batteries. This internal clock, their circadian rhythm, makes sure they don't waste precious energy making light when it's already bright outside. It's a purely nocturnal defense, timed perfectly for when it's needed most.
Okay, so we know who our culprits are. We know how they make their light, but that brings us to the biggest mystery of all, the motive. Why? Why go to all this energetic trouble to create a flash of light? Well, the leading theory has a fantastic name. It's called the Burglar Alarm hypothesis.
Now, here is the crucial point. You might think the flash is just meant to startle whatever tiny creature is trying to eat it. And maybe it does, a little bit, but that is not its main purpose. The real strategy is so much smarter.
It's literally a living burglar alarm. The dinoflagellate is calling for backup. So picture this, a small grazer, something like a copepod, comes along and tries to munch on the dinoflagellate. The moment it's attacked, it lights up like a firework. That flash acts like a spotlight, completely exposing the little copepod in the dark water. And what does that light attract? A bigger predator, like a fish, who sees the easy, illuminated meal, swoops in, and eats the dinoflagellate's attacker. It's a brilliant, if a bit self-sacrificial way to protect the whole population.
But, like any good story, this one has a dark twist. Because the same incredible phenomenon that creates all this breathtaking beauty can also be a sign of something much, much more menacing.
Yeah, this really shows the paradox, the two faces of this glow. On one hand, you have this magical beauty, this sophisticated defense system that's a wonder of evolution. But on the other hand, when these organisms bloom in massive numbers, they create what are known as red tides, which can be packed with neurotoxins and create vast oxygen-starved dead zones in the ocean. These events are called harmful algal blooms, or HABs for short, and they are a really serious threat.
When all those billions of cells in a bloom die and decompose, the process sucks all the oxygen out of the water, creating those dead zones that suffocate fish. And remember our rogues gallery? Some of those species produce toxins that can build up in shellfish and cause poisoning in humans who eat them. Sometimes, the sheer density of the cells in the water can literally clog the gills of fish.
So, this brings us to the final and maybe most critical part of our story, our own connection to this silent war, and how our actions on land are actually influencing this glow in the ocean. It turns out we're basically adding fuel to the fire. Nutrient pollution, so things like fertilizer runoff from farms and wastewater from our cities. All of that acts like a super fertilizer for these dinoflagellates. This can trigger blooms that are way bigger, last much longer, and are potentially way more dangerous than they would be naturally. We might be making the light shows brighter, but we're also making them more deadly.
And that brings us right back to where we started. The next time you see that magical, otherworldly glow on the water, what will you see? Will you see just one of nature's greatest wonders, or will you now see a beautiful, brilliant, but urgent warning sign from an ocean that might be in serious trouble? It's something to think about.